Why is it crucial to understand the workings of an anesthesia machine, you might ask? Well, it's like asking why a pilot needs to understand the cockpit before taking off. The anesthesia machine, a vital part of any operating room, is the cockpit for an anesthesiologist. Its complexity is a testament to its importance, as it's responsible for keeping patients safe and comfortable during surgical procedures. The anesthesia machine plays a critical role in patient safety. It delivers a precise mix of anesthetic gases and oxygen to the patient, maintaining the patient's unconscious state while also monitoring vital signs. This ensures that the patient stays safe throughout the surgery. A slight miscalculation or malfunction could result in serious complications, including brain damage or even death. Hence, understanding the machine's operations is crucial to prevent such mishaps. Furthermore, the anesthesia machine is the cornerstone of anesthesia administration. It's not just about putting a patient to sleep, it's about maintaining an optimal balance. Too much anesthetic can cause harm, while too little might lead to the patient waking up during surgery, a phenomenon known as anesthesia awareness. The anesthesia machine allows anesthesiologists to strike the right balance, ensuring the patient's comfort and safety. The machine's complexity, while daunting, is necessary. It houses various systems such as the pressure systems, the anesthetic gas scavenging system, the ventilator and breathing system, and the monitoring systems. Each of these plays a unique role, working together to deliver safe and effective anesthesia. Understanding each component allows anesthesiologists to utilize the machine to its full potential, optimizing patient care. In conclusion, the anesthesia machine is more than just a piece of equipment. It's a lifeline, a guardian, and a tool of precision, all rolled into one. Understanding its workings is not just about technical know-how, it's about ensuring patient safety and delivering the best care possible. So, a thorough understanding of this machine can make a significant difference in the operating room. First off, we have the master switch and circuit breakers. These might seem like simple components, yet their importance in operating the anesthesia machine cannot be overstated. They are, in essence, the guardians of the machine's power supply. The master switch, as the name suggests, is the ultimate authority. It is the initial step in powering up the machine. When you flip the master switch, you're essentially giving life to the anesthesia machine. It's like the heartbeat of the machine, keeping the flow of power steady and consistent. Now let's move on to the circuit breakers. They are the unsung heroes of electrical safety. They monitor the flow of electricity and, in the event of an overload, they spring into action, breaking the circuit and preventing a potential catastrophe. Think of them as the protective shields of the machine, always on the lookout for any electrical mishaps. In the grand scheme of the anesthesia machine, the master switch and circuit breakers play a pivotal role. They ensure that the machine functions smoothly by maintaining a steady flow of power and protecting the machine from electrical overloads. Let's not forget that the anesthesia machine is a complex piece of medical equipment. It is designed to deliver a mixture of gases and vapors to maintain and alter a patient's level of consciousness and pain sensation during surgical procedures. So, it's crucial that the machine operates properly and safely at all times. In summary, the master switch and circuit breakers are like the gatekeepers of the anesthesia machine. They control the power supply, ensuring the machine operates safely and effectively. By understanding their function and importance, you're taking the first step towards becoming a safe and competent operator of the anesthesia machine. So, remember, the next time you switch on the anesthesia machine, acknowledge the role of the master switch and circuit breakers. They're not just simple switches, they're complex electrical components designed to ensure the safe operation of the machine. Understanding these controls is the first step towards operating the anesthesia machine safely. With this knowledge, you're one step closer to mastering the art of anesthesia. Next, we delve into the pressure systems of the anesthesia machine. Now imagine the anesthesia machine as a city. In this city, there are 3 districts, each with a unique role and function. These districts are the high, intermediate, and low pressure systems of our anesthesia machine city. Let's start with the high pressure system, the first district of our city. This system begins at the anesthesia cylinder and ends at the cylinder pressure regulator. It's responsible for regulating the high pressure from the cylinder, which can reach up to 2,000 pounds per square inch, down to a more manageable level. If we picture this as a city district, it's the gatekeeper, ensuring the pressure entering our city is safe and manageable. Next, we move to the intermediate pressure system, the second district of our city. This system starts at the machine's pressure regulator and ends at the flow control valves. It further reduces the pressure to a safe level around 45 pounds per square inch before it reaches the flow meters. This district is like the city's traffic control center, ensuring the pressure flows smoothly and safely through the city's streets. Finally, we arrive at the low-pressure system, the third and final district. This system begins at the flow control valves and ends at the common gas outlet. Here, the pressure is reduced even further, to just above atmospheric pressure. This district is like the city's residents, receiving the pressure and utilizing it in the most effective and efficient way possible. Each of these systems, these districts, is integral to the overall operation of the anesthesia machine. They work together, ensuring the pressure from the cylinder is reduced to a safe, usable level. They help to deliver the anesthetic agents, like the city's mail delivery system, ensuring each resident receives exactly what they need, when they need it. These pressure systems play a vital role in delivering the anesthetic agents to the patient. Let's turn our attention to the anesthetic gas scavenging system. This part of the anesthesia machine plays a pivotal role in maintaining a safe and healthy operating room environment. But how exactly does it do this? Well, it all boils down to its primary function: to remove excess anesthetic gases from the operating room. You see, during the anesthesia process, it's inevitable that some anesthetic gases escape from the patient's breathing system. These gases, if left unchecked, can build up in the operating room air, posing a potential health risk to the healthcare team and even the patient. This is where the anesthetic gas scavenging system comes into play. Operating like a vigilant guardian, the scavenging system captures these escaped gases before they have a chance to contaminate the environment. It does this by connecting to the anesthesia machine's patient breathing circuit. Any excess gases that aren't metabolized by the patient are captured and redirected away from the patient and the healthcare team. But where do these gases go? The scavenging system, true to its name, scavenges these gases, channeling them into a disposal assembly. This assembly typically consists of two main parts: a reservoir to hold the gases momentarily, and a vent to release them safely out of the building and into the outside air. The anesthetic gas scavenging system is not just about maintaining a clean air environment, though. It also plays a role in controlling the pressure within the patient's breathing circuit. By removing excess gases, it helps prevent the buildup of pressure that could potentially cause harm to the patient. This system is a testament to the intricate design and thoughtfulness that goes into the construction of an anesthesia machine. Every component, every mechanism, is there for a reason, playing its part in ensuring the safety and efficacy of the anesthesia process. In essence, the anesthetic gas scavenging system is a silent hero of the operating room, tirelessly working to ensure a safe environment for both the patient and the healthcare team. Now, we'll explore the ventilator and breathing system. Let's dive right in. The ventilator and breathing system are the unsung heroes of the anesthesia machine. They're the lifelines that ensure a patient keeps breathing, even when under the heavy influence of anesthetics. The ventilator is a mechanical device that replaces or supplements the patient's natural breathing. It generates a flow of gas into the patient's lungs, then allows it to flow out again, simulating the process of breathing. Ventilators have several key components, including a driving gas source, valves to control gas flow, sensors to monitor pressure and volume, and an alarm system to alert the anesthetist to any problems. The breathing system, on the other hand, is the conduit that delivers the anesthetic gases and oxygen from the machine to the patient. It also removes carbon dioxide that the patient exhales. The main parts of the breathing system are the breathing circuit, the carbon dioxide absorber, and the adjustable pressure limiting valve. The breathing circuit is like a two-lane highway. One lane carries fresh gas from the machine to the patient, while the other carries exhaled gas back to the machine. The carbon dioxide absorber then removes carbon dioxide from this exhaled gas before it's recirculated. The adjustable pressure limiting valve is our safety net. It prevents excessive pressure from building up within the system, which could potentially harm the patient's lungs. It does this by venting excess gas into the atmosphere. It's a symphony of precision engineering and medical science. Each component has a critical role to play, and their functions are closely monitored and controlled. The ventilator and breathing system work in harmony to maintain a stable, controlled environment for the patient's respiration during surgery. These systems are essential for maintaining the patient's respiration during surgery. They are a testament to our commitment to patient safety and comfort. So the next time you see an anesthesia machine, remember, it's not just a machine, it's a lifeline. And that's why understanding these intricate systems is so crucial for anyone involved in delivering anesthesia care. Lastly, we'll look at the monitoring systems of the anesthesia machine. These systems are the unsung heroes of the operating room, constantly keeping a close eye on the patient's condition throughout the procedure. First up, we have the gas monitors. These little marvels are responsible for ensuring the correct mixture and concentration of gases are delivered to the patient. They carefully and continuously analyze the gases being delivered, including oxygen, nitrous oxide, and the anesthetic agent itself. They alert the anesthesiologist if there's any deviation from the predefined levels, helping to prevent any potential complications. Next, let's talk about the pressure monitors. They are tasked with the job of overseeing the pressure within the breathing system. As you can imagine, maintaining the right pressure is essential for the patient's comfort and safety. If the pressure is too high, it could cause barotrauma, and if it's too low, the patient might not receive enough oxygen. The pressure monitors ensure that the pressure stays within the safe limits, providing real-time feedback to the anesthesiologist. Finally, we come to the vital signs monitors. These are perhaps the most familiar to many of us, tracking the patient's heart rate, blood pressure, temperature, and oxygen saturation. They provide essential information about the patient's overall health and how they're responding to the anesthesia. Any sudden changes in these vital signs could indicate a problem, allowing the anesthesiologist to intervene quickly and effectively. Together, these monitoring systems form a comprehensive network of vigilance. They ensure that the anesthesiologist has a complete and accurate picture of the patient's condition at all times. They help to detect any potential issues early, allowing for immediate intervention and the best possible patient outcomes. These monitoring systems are crucial for ensuring patient safety during anesthesia. They are the silent sentinels, tirelessly watching over every breath, every heartbeat, and every moment of the patient's journey under anesthesia. To wrap up, let's summarize the main points about the anesthesia machine. The anesthesia machine is an incredibly important piece of equipment in any surgical procedure. It's the control center for delivering the anesthetics that allow surgeons to perform their work while keeping the patient's pain and discomfort at a minimal level. Understanding each of its components is crucial for anyone involved in the anesthetic process. Firstly, we have the master switch and circuit breakers. These are the first points of contact with the machine. The master switch powers the machine, and the circuit breakers protect the machine from electrical overload. They're like the gatekeepers, ensuring that the machine operates within safe electrical parameters. Next, we move on to the pressure systems. These systems regulate the flow of gases within the machine, ensuring a balanced and controlled delivery of anesthetic gases to the patient. They're the heart of the machine, if you will, pumping life-giving gases to where they're needed most. Then, there's the anesthetic gas scavenging system. This system is responsible for safely removing excess anesthetic gases from the operating room. It's the unsung hero of the machine, quietly protecting the surgical team from unnecessary exposure to anesthetic gases. Now let's talk about the ventilator and breathing system. These systems work hand in hand to assist the patient's breathing while under anesthesia. The ventilator helps to maintain a regular and controlled breathing pattern, while the breathing system delivers the anesthetic gases. They're like a team of dedicated caregivers, ensuring the patient's respiratory needs are met. The monitoring systems are next on our list. They're the eyes and ears of the machine, providing real-time data on the patient's vital signs and the performance of the machine itself. They keep a constant vigil, alerting the anesthetist to any potential issues that could arise during the procedure. Finally, we come to the importance of understanding each component and how they work together. Each part of the anesthesia machine has a specific role to play, and understanding these roles is key to ensuring the safe and effective administration of anesthesia. It's like a well-rehearsed orchestra, with each instrument playing its part to create a harmonious performance. In conclusion, the anesthesia machine is a complex but vital piece of equipment. Each part, from the master switch to the monitoring systems, plays a crucial role in ensuring the safe and effective delivery of anesthesia. Understanding each of these components and how they work together is key to patient safety and effective anesthesia administration. An in-depth understanding of the anesthesia machine is key to patient safety and effective anesthesia administration.